Hello and a very good afternoon to everyone. I hope all of you all are observing the lockdown that has been instituted all across the country. These are very tricky times. It's very important for all of us to observe the lockdown and the curfew restrictions, and please take care and stay safe. We'll be continuing today with the first chapter, which is electric charges, fields and potentials. Balu sir was teaching the last 5 lectures. Today the 6th lecture. Unfortunately, on account of the lockdown, Balu sir is unable to take the class. So I'm substituting for Balu sir. This is Sridhar sir from DCFL. I will do today's lecture for you. So if you look at electric charge, just look at the bigger picture. What all sub-concepts or chapters do you have in the chapter of electric charges and field? You have the idea of Coulomb's law, which is the first thing that Balu sir finished for you all. It's already done. 2 charges, the experience of force, k q1 q2 by r squared. And then Balu sir also introduced the idea of electric field. So the idea of electric field was introduced. I will build up on the electric field, and then tomorrow I will teach about electric field lines. After this you have Gauss's law. Then you have electric potential, potential energy and work energy theorem, and finally electric dipoles. So the only thing about this chapter is it is a little new. You have learnt about Coulomb's law in 10th standard, but the idea of electric field, then potential, Gauss's law, all these are quite new. This is an important chapter. It will need 1-2 times of reading and rereading to become clear and thorough in this chapter. So I strongly suggest take your time, review the lecture afterwards, read your NCERT book, practice the examples, practice the homework questions, till you become confident and comfortable with all the concepts in this chapter. So we'll be going to electric field. If I look at electric field, there also you have basically 3 categories. Electric field due to a point charge, which Balu sir has already covered. Electric field due to 2 point charges in a line. And then electric field when you have 3 or more point charges in a plane. So you have point charges placed on the corners of a triangle, on the corners of a square, on the corners of a hexagon. In all these kinds of situations, how do you find out the resultant or the net electric field at any given point? So before we do that, let's do a quick recap. If I just recap to a single charge, what is the electric field? If I have a charge over here Q, I have a point here P, and suppose the point P is at a distance R, then the electric field at P, all of you all know, you've already learnt it, is equal to kq by r squared, also written as q by 4 pi epsilon naught r squared, and the value of 1 by 4 pi epsilon naught or k is 9 into 10 power 9 q by r squared. When you do this, q will have to be in coulombs, r will have to be in meters, SI units, and the electric field will be newtons per coulomb. So this formula you've already seen. You've done some simple examples using this formula. The important point to keep in mind is electric field a scalar or a vector. Electric field is a vector, which means it also has a direction. So how do I find the direction of the electric field? When I have a positive charge and I have a point P over here, the direction of electric field is along the line joining the charge to the point P, and it is radially outward. This will be the direction of the electric field. If I have a point P dash over here and it's a positive charge, how do you get the direction of the electric field at P dash? Draw a line joining the charge to the point P dash, extend it outward, radially outward is the direction of the electric field. How about if I have a negative charge? I have a negative charge over here and I have a point P, and I want to find the direction of the electric field at the point P. Once again, it is along the line joining the charge to the point P, but if it's negative, it is going to be radially inward. Here it was radially outward. From the center you have the radius and it goes outward. Here from the center it is radially towards the center. If I have a point P dash over here and I want the direction of the electric field at P dash, draw a line joining the charge to P dash and it's towards the charge, inwards. This is the direction of the electric field at P dash. So these are your basic ideas when you have electric field due to a single point charge. The magnitude of the electric field is kq by r squared, or q by 4 pi epsilon naught r squared, and the value of k is 9 and 10 power 9, and it's a vector, therefore it has a direction. So suppose I have two charges. I have two charges and I want to find the resultant electric field along a line joining the two charges. This also has been done for you all earlier in the earlier lecture. Suppose I have a charge here q, let this be positive q1, and I have another charge here q, which is also positive q2. I want to find out what is the electric field at various points on the line joining q1 and q2. So suppose I have a point A over here, I have a point B over here, and I have a point C over here. Now the magnitude is kq by r squared, that you can easily do. The only thing you have to be careful about is the direction of the electric field. Now these are positive charges, therefore your directions will be radially outward. So if I have the point A over here and I take charge q1, this is the line joining q1 to the charge A. Radially outward means E1 will be to the left. Because of charge q2, it is also positive. If I have the point A, again the line joining them will go to the left, and the electric field E2 is also to the left. So the net electric field at A is E1 plus E2 to the left. If I take the point B, because of q1, the electric field will be to the right, this is E1, and because of q2, the electric field will be to the left, E2. So your net electric field at B will be, electric field at B is E1 minus E2 to the right. And I said for A, electric field at A will be E1 plus E2, but to the left. Now if you take the point C over here, because of q1, the electric field will be to the right, and this will be E1, and because of q2, that also the electric field will be to the right, E2. So the electric field at C will be E1 plus E2, and to what direction? To the right. So there is a fundamental idea on the direction of electric fields. It's very important that you get this very clear how the field directions work. I'll just give you 5 seconds. You can copy this diagram. Okay, so next idea you may have, suppose I again have two charges, but now I have q1 and q2, but q1 is positive and q2 is negative. Now what will be the direction of the field lines, electric field at various points? Once again, all electric fields will be along the line joining the charge to the point. Suppose I have A, because of q1 you're going to have E1 to the left, q2 is going to attract you in, therefore E2 will be to the right. If I have a point B, q1 will repel you, so E1 will be to the right, and q2 is going to attract you, so E2 will also be to the right. So here it will be E1 plus E2. If I have a point C over here, q1 again will repel you, you have E1 to the right, but q2 is going to attract you, it will attract you inwards, and E2 to the left. So along with the magnitude of the electric field, you also have to be very, very careful about the direction of the electric field. Again, a very common mistake children do is they use the direction like I've drawn here, E1, E2, E1, E2, E1, E2. They use these directions, but then when they substitute for E, they also put the negative sign. Suppose E2 is negative, they will write E2 is minus kq2 by r squared. That is wrong, then you're doing it 2 times. E1, E2 is only the magnitude, will be positive. The direction is given by the arrow here. So you have the net electric field is E2 minus E1 to the right, and over here E2 and E1 are both positive. Just take the magnitude of the charges Q1 and Q2. Here the net electric field is E1 plus E2 to the right, and here the net electric field is E1 minus E2 to the right. Okay. In the value for E1 and E2, you will not put the signs of Q, you will simply say magnitude KQ by R squared, and based on whether they are positive or negative, you will assign the directions of the electric fields. So in this manner, you can find the electric field because of 2 point charges along the line joining the two charges. You have one more number coming up over there. For doubts, you can call the WhatsApp number 72590-40704. Periodically, this number will keep showing up. Write it down, note it down in your notebook. If you have any doubts, you can WhatsApp it, and a teacher is actually live with you all right now. As the class is going on, the teacher will answer your doubts. Please post only physics doubts. Don't put doubts on voice not heard, audio not clear, video not clear. This number is only for putting your physics doubts, and a teacher will definitely either reply back by text, or if necessary the teacher would write the answer down, take a photograph and put it back to you. So any doubts that you're having in the class, you can ask us right away and get your doubts clarified. Okay, now doing remote classes is a little strange for all of us. I'm used to having students in front of me that I can stare you down and see if you're writing what I'm saying or not, if you're paying attention to what I'm doing or not. Remotely, for all that I know, you're lying down in bed and reading a storybook while I'm drawing off in the background. Yep, so I don't have much control over it. But if you want to benefit from this class, it is very critical that you have your notebook open and you write down all the points. So definitely I would say make the heading field due to two charges and have this diagram copied in your notebook along with the directions that are there. I might be going fast because I can't see if you've written it or not. If that happens, you can always go back, look at the recording, or you know what, even while this is going on, you can pause the video, you can write it, and then you can continue watching. That's a big advantage when you have an online class, that if I'm going to the next slide very quickly, just pause the video, see what it is, write down all the points, and then you go on. It's very important your notebook is intact, proper, and pakka with all the information. Okay, so now we're going to today's lecture, which is largely what is a field due to 3 or more charges. Now if I have 2 charges in a line, I can do it. 3 charges in a line also, I can use the same logic. But here I'm having 3 charges in a plane. So charges are in a plane, and before we solve it, there's some important results that we should recap that is helpful to us. So if for example I have 2 charges here, Q1 and Q2, I have a point P over here. Because of Q1, I'll have electric field E1. Because of Q2, I'll have electric field E2, and the 2 fields are at some angle theta. I want to find out my resultant electric field. Now we've done in first year resultant of 2 vectors A and B with an angle theta between them. I hope you remember the resultant. R is equal to square root of A squared plus B squared plus 2AB cos theta. That is the formula for the resultant of 2 vectors. Now here E1 and E2 also vectors. Angle between them is theta, so I can use the same formula. E resultant is equal to E1 squared plus E2 squared plus 2 E1 E2 cos theta under square root. So E resultant is equal to E1 squared plus E2 squared plus 2 E1 E2 cos theta whole raised to the power half. So all of you all kindly note this down. Charges in a plane. You will use the result from vector algebra, that when I have two fields, 2 vectors E1 and E2, angle theta, then E resultant is E1 plus E2 plus 2 E1 E2 cos theta. Now very important note, how do I define my theta? Theta is defined with E1 and E2 placed tail to tail. So, if I look at my two vectors E1, this is the vector E1, this is the head and this is the tail of E1. If I look at E2, this is the head and this is the tail of E2. So, E1 and E2 have been placed tail to tail. You cannot do this, you cannot write E1 like this and E2 like this. Then the angle over here is obviously different from the angle over here. Now, the head of E2, E2's head is on the tail of E1. This is wrong, you can't do that. Whenever you find the electric field, you got to place the tail of the two vectors together. Please note this down, mark it, because this is very important. This is a common mistake students make when they solve problems. They don't note down and draw the vector and get the angle of theta correctly. So, the theta is calculated with the two vectors placed tail to tail, and the formula that you will use is E resultant is E1 squared plus E2 squared plus 2 E1 E2 cos theta. Okay. So, let us now go solve a problem. Here is an example. ABC is a right angle triangle and the sides are 0.3, 0.4 and 0.5. So, it forms a triad. So, that is obviously correct. Where are the charges placed? The charges are placed at ends A and B, at corners A and B. At A you have 5 microcoulomb, at B you have a 3 microcoulomb, and look at the sign, both are positive. A is also positive, B is also positive. What are you expected to find? Find the electric intensity at the point C. You want to find the electric field at the point C. Very nice, we will solve it. But just quickly, let us look at it. Now, how many charges do we have? 2. Therefore, how many fields will we have? 2. What are those 2 fields? Because of A, you will have electric field at C, and what will the direction be? Along AC and radially outward. So, let me call this E1. And because of B, you are going to have electric field, again it's positive. So, along BC radially outward, this is E2. And what is the angle between them? It's the same angle theta that we have here. And if this is theta, what is sine theta? 0.4 by 0.5 is 4 by 5. What is cos theta? Because the formula is E1 squared plus E2 squared plus 2 E1 E2 cos theta. Cos theta will be 0.3 by 0.5 or 3 by 5. So, keeping these in mind, if I just get the magnitude of E1, magnitude of E2, I have theta, I can solve and get my answer. Is the logic clear as to how you want to do it? Yep. Okay, now it's just arithmetic. Now the physics of it is over, it's pure arithmetic now. Don't make mistakes when you solve the arithmetic. So, let's go on to it. Let me just redraw the diagram once again. So, you have 5 and 3. So, you have 5 microcoulomb, 3 microcoulomb and 0.4 and 0.3. This is 0.4 meters, 0.3 meters, 0.5 meters, and this is point C, this is A and B. I said E1 was because of A. So, if I want to get the magnitude of E1 is 9 into 10 power 9 K into Q. What is the charge? 5 micro. Micro is 10 to the power minus 6. 5 into 10 power minus 6 Kq by r squared. What is the distance between A and C? Is 0.5 meters. So, 0.5 times 0.5, which is equal to, okay, I am pulling up a calculator here, 9 into 5 into 4, it becomes 180, 180 into 10 to the power 9 minus 6, 3 Newton per coulomb. That is your electric field E1, the electric field at C due to the charge at A. Now, I want to get E2. E2 is because of the 3 microcoulomb located at B, its electric field will be horizontal, E2 to the right. So, what is E? K, 9 into 10 power 9 into Q is 3 micro. So, once again 10 power minus 6 by what's your distance now? 0.3 times 0.3, which is equal to, so it becomes 9 cancels off 3, 300 into 10 to the power 3 Newton per coulomb. This angle is theta. So, what is cos theta? cos theta's adjacent side by hypotenuse. So, it becomes 0.3 by 0.5 or 3 by 5. Let us plug it all in together. Therefore, the resultant electric field is equal to E1 squared. I am going to take the 10 power 3 outside. So, or I will write this as 1.8 into 10 power 5. This is equal to 3 into 10 power 5. So, I will take the 10 power 5 out. 1.8 the whole squared plus 3 the whole squared whole to the power half into 10 to the power 5, and 1.8 the whole squared is 3.24 plus 3 the whole squared is 9. That's I'm sorry, I forgot one more term, a squared plus b squared plus 2ab cos theta plus 2 into a is 1.8 into 3, 2ab into cos theta is 3 by 5, all of that raised to the power half into 10 power 5. So, 1.8 into 1.8 is 3.24 plus 3 squared is 9 plus 2 into 1.8 into 3 into 3 divided by 5 is 6.48 whole to the power half into 10 to the power 5, which is equal to 6.48 plus 9 plus 3.24, and you take the square root of that is 4.33. 4.33 into 10 to the power 5 Newton per Coulomb. So, that then would be the net electric field at the point C. Let me just check and see my answer is correct. Yep, this 4.33 10 power 5 Newton per Coulomb. So, my answer is indeed correct. Let us pause it for a moment over here and just see what we have done, how we have solved it. We had charge 5 microcoulomb at A. So, it had electric field E1 and the magnitude we found to be 1.8 10 power 5 Newton per Coulomb. We had 3 microcoulomb at B, it had electric field E2, we found its value to be 3 10 power 5 Newton per Coulomb. The two electric fields were at an angle theta. The value of theta cos theta is 3 by 5. I plugged in all the values, a squared plus b squared plus 2ab cos theta, and this is the arithmetic and the math, and the answer is 4.33 10 power 5 Newton per Coulomb. Okay. This is a very common standard problem in PUC or CBSE also. You will have two charges either in the corners of an equilateral triangle or a right angle triangle or a right angle isosceles triangle, any variation. So, theta may be 60 degrees or 45 degrees or 90 degrees. These are your standard values. Plug it in and get your answer. Okay. Let us go to example 2. Again similar. Like I said, now you have an equilateral triangle. All three distances are 0.1 meter, 0.1 meter, 0.1 meter. How many charges do we have? We have 2 point charges, Q1. Q1 is at this point and Q2 is at this point. And you want to find the electric fields at A, which is here, electric field at B, which is here, and electric field at C. Okay. So, nothing new about it. The logic will be same. Now, if I look at the point A, it is on the line joining Q1 and Q2. So, there is not much vector algebra here. You simply get E1, E2 and then decide whether you are going to add or subtract. Now, look at the signs. Q1 is positive or negative. Q1 is plus 10 power minus 8. So, Q1 is positive and Q2 is minus 10 power minus 8. So, Q2 is negative. That you have to keep in mind. That will give you the direction of the electric fields due to these two charges. And then systematically find the magnitude, find the direction, find the resultant for point A, for point B and point C, excuse me. So, shall we do it? All of you all just pause the video for a moment and copy down this diagram, copy down the question. You can pause the video, so I am going to go on, you can always pause the video. Okay. So, if I want to solve it, so I have drawn back the diagram once again. I want to find electric field at A. Now, this is 0.1 meters, therefore, the distance from here will be 0.05 meters. Similarly, the distance from here to here 0.05 meters. And what is the value of Q1 is plus 10 power minus 8 and minus, this is positive and this is negative. Okay. So, because of positive q1 the electric field at A, because of positive q1 the electric field at A will be to the right or be to the left? Will it repel or will it attract? It is positive, so it is going to repel, it is going to push it outward, therefore E1 is to the right. And now you have a negative q2, negative q2 is going to attract or repel? The negative charge will attract, it will pull it in, and therefore E2 will also be to the right. So, your net electric field at A will be E1 plus E2 to the right. Simple. Now, all you have to do is get the magnitude. What is E1 going to be? K 9 into 10 power 9 into Q 10 power minus 8 kq by r squared, 0.05 into 0.05, which is equal to 3.6 into 10 to the power 4 Newton per Coulomb. Yep, to the right. Now, if I want to get E2, E2 will be 9 into 10 power 9 into, now the charge is negative, but I will only get magnitudes over here. So, I will still write 10 power minus 8. I will not write minus 10 power minus 8. Okay, it will be into 10 power minus 8 by the distance is the same, 0.05 into 0.05. So, the answer will still be 3.6 into 10 power 4 Newton per Coulomb. Therefore, your resultant net electric field at A is simply E1 plus E2, which is 3.6 plus 3.6, 7.2, 7.2 into 10 power 4 Newton per Coulomb to the right. Or you can write two words N. In PUC or in board examinations, when you give the answer for electric field, you will have to give the direction. If you don't give the direction, you will lose half a mark or 1 mark. So, the answer has to be both magnitude and direction. So, electric field at A will be 7.2 into 10 power 4 Newton per Coulomb directed to the right. Okay, simple. Yes, let us go next. We want to get electric field at B. This is the point B. I want to find what is the electric field at B. Once again, Q1 is positive, Q2 is negative. Distance between B and Q1 is 0.05, whereas distance between B and Q2 all the way here is 0.15 meters. Keep that in mind. So, your distance between the charge and the point B is different. Now, Q1 is positive. Will it attract or repel? It will repel. Therefore, the direction of electric field at B will be to the left, whereas Q2 is negative. It is going to attract, it is going to pull you inwards. Therefore, E2 will be towards Q2 or to the right. So, your resultant electric field will be E1 minus E2. E1 was to the left, I have taken it positive. So, E1 minus E2 to the left will be your resultant electric field. So, let us get E1 and E2. E1 is 9 into 10 power 9 into Q1 is 10 power minus 8 by r squared. Oh, same value 0.05, 0.05. They have been very sweet. They have given us easy numbers, repetitive numbers, and this we found out to be already 3.6, right. So, 3.6 into 10 to the power 4 Newton per Coulomb. This was to the left. And E2, if I get electric field 2, because of Q2 will be K 9 and 10 power 9 into Q is 10 power minus 8. Once again, I will not put the negative sign minus, I just put it as 10 power minus 8, and r squared 0.15 times 0.15. So, it becomes 9 divided by 0.15 divided by 0.15 is 400. So, it is going to be 400 into 10 power 1, which is going to be 0.4 into 10 power 4 to the right. Therefore, E resultant will be E1 plus E2 or E1 minus E2. They are in opposite directions. So, I will subtract, will be E1 minus E2, which is 3.6 minus 0.4 is 3.2 into 10 power 4 to the left. E1 was greater, E1 was to the left. So, the answer is 3.2 10 power 4 Newton per Coulomb. Sorry, better put the units, otherwise you lose half a mark, to the left. That takes care of the electric field at B. Nothing new. We simply took charge Q1, found E1, charge Q2, found E2, get the distances clearly, don't make arithmetic mistakes, find the directions of E1, E2. In this case, you will subtract to get the net electric field. Now, next we have to go for the point C, electric field for the point C. Now, the point C is in a plane, it's not in a line joining Q1 and Q2, so you've got to use the E1 squared plus E2 squared plus 2 E1 E2 cos theta formula. Because of Q1 is positive, this is a nice one, Q2 is negative. So, let us look at the directions. Q1 is positive, it is going to repel, therefore, this will be the direction of E1. Now, Q2 is negative, it is going to attract, therefore, if it attracts, it is going to pull it inwards, this is the direction of E2. Yep. Now, the angle between them is taken putting them tail to tail. So, you have to put them tail to tail. This is the angle between them. Equilateral triangle, this is 60. So, theta is 120 degrees. A common mistake students will make, and you shouldn't make this mistake, I am just drawing it for you. You will say E1 is like this, or you generally say E1 is like this, E2 is like this, and you will say angle between them is 60 degrees. This is wrong, you can't do it. The head cannot be on the point, they should be tail to tail. So, E1 is going outward, E2 is going this way, and the angle between them is 120 degrees. Now, let us solve it. What is the distance? 0.1, 0.1. So, E1 is K 9 to the 10 power 9 into Q 10 power minus 8 by R squared, 0.1 times 0.1, which is 211, 9 to the 10 power 3 Newton per Coulomb, and it's that way. E2 is also the same because your charge is also the same and the distance is also the same. Therefore, it does not change, it will be 9 to the 10 power 3 Newton per Coulomb. Theta, angle between them is 120 degrees. What is cos 120? It's cos 90 plus 30 will become minus sin 30, which is minus half. Cos theta is minus 1 by 2. Therefore, your E at C, E resultant, is equal to 10 power 3 I can take out, 9 squared plus 9 squared plus 2 times 9 into minus 1 by 2 whole raised to the power half into 10 to the power 3, which becomes 9 squared plus 9 squared minus 9 squared. 1 9 squared goes off. See, 9 into 9, 9 squared, 2 into half. So, 2 cancels off. This is nothing but minus 9 squared. So, 1 9 squared cancels off. 9 squared power half is simply 9 into 10 to the power 3 Newton per Coulomb. And in which way will it act? The resultant of both of these will be acting this way. E resultant along the bisector towards or parallel to Mn to the right. So, the resultant electric field will be towards the right parallel to Mn, and the magnitude is 9 into 10 power 3 Newton per Coulomb. So, this was the three results. Let us check if the answer is correct. 7.2, 3.2 and 9. Yep, my answers are correct, parallel to Mn, parallel to Mn. Okay. So, let us quickly recap. We had two charges Q1 and Q2 located at M and N. I was asked in the first case to find the electric field at A. Here they were in the same line. I simply found E1, E2 and found whether I should add or subtract. Let us go back to that solution. E1 was to the right, E2 was also to the right, so I added and got E1 plus E2. In example for the point B, E1 was to the left whereas E2 was to the right. Therefore, E resultant was E1 minus E2. And the third example when I came C, E1 and E2 are 120 degrees apart. Therefore, I use the formula E1 squared plus E2 squared plus 2E1 E2 cos of theta. So again, it's the same formula. Depending on whether it's a line or a plane, you will use either E1 plus or minus E2 or the vector formula for rotation. Is it clear? Let's do one more example. Same idea, we will take it forward. Yep, what do we have here? We now have a square. What is the side of the square? 0.02 meters. You have a square of side 0.02 meters. You want to find there is 4 charges, so it's not 2, you have 4 charges. You have plus q, minus q, plus 2q and minus 2q. You have 4 charges on the corners of the square. You want to find the magnitude of the electric field at the center O. You want to find what is electric field at O equals how much. Very nice. So now you have 4 charges, so how many electric fields will you have? 4 electric fields. And the electric field will be along the line joining the charge to the point O. Only thing I keep in mind, seeing whether it's plus or minus, put the direction carefully. That's all. This is very simple afterwards. So take plus q, attractive or repulsive, it will repel. So if I call this 1, or let's call A as 1, 2, 3, 4. So I start with plus 2q. Plus 2q will repel, so it will go this way. This will be electric field E1 due to the charge at A. Now if I go to B, B is now minus q. Minus q means it will attract or repel. It will attract, so this will be E2, which is charge at B, charge at O due to the minus q at B. Now you have plus q at C. So plus q again will repel, so it goes this way. This will be E3, electric field at O due to the charge plus q at C. And last you have D. D is also negative. Negative means it will attract. So you have electric field E4 this way. Electric field E4 is the electric field at O due to the charge minus q, minus 2q located at D. So you have 4 directions. Don't worry. Now E1, E3 are opposite, so I can subtract. E2 and E4 opposite, I will subtract. Then I'll simply get 2 electric fields which are along the diagonals, and I'll get my formula to get the answer. E1 square plus E2 square plus 2E1 E2 cos theta whole power half. So let's go through it one step at a time. Each charge, by the way, Q is 0.02 microcoulombs. So let's go. You want to find the field at O. So I said because of A, this is E1. So E1 is equal to K 9 at 10 power 9 KQ. Q was, it's 2 times 0.02, 2 times 0.02 micro, so 10 power minus 6 KQ by R squared. What is the distance? If this is 0.2, if I have a square, of side, let me write here, if I have squared of side A, what is the diagonal? Diagonal is root 2 times A. Therefore, what is my semi-diagonal? Half the diagonal. Semi-diagonal is half of that, becomes A by root 2. So my distance from here to here for all the charges, distance from the corner to O is A by root 2, and A is 0.02. So 0.02 by root 2 the whole squared. That is E1. And now just do the arithmetic, the whole squared. So 9 times root 2 the whole square becomes 2 times 2 times 2 times 0.02 divided by 0.02 divided by 0.02 is 1800, 1800 into 10 to the power 3 Newton per Coulomb is the electric field at O due to 2q. Now I want to go to the point B, so this now will be E2. E2 is equal to K 9 at 10 power 9 into only one charge Q. So 1 times 0.02 into 10 power minus 6, because it's 0.02 microcoulomb, divided by the distance will still be 0.02 by root 2 the whole squared. So the same answer as before, except that I don't have 2, so it will become 900 into 10 power 3 Newton per Coulomb in this direction. Yep. Now E3 is because of C, C is plus Q, so you will have E3 acting this way. E3, I don't have to substitute other values. It is again Q, so it will be 900 into 10 power 3 Newton per Coulomb. And lastly, you have D. D is minus 2Q. It will attract you inwards. So this is E4. So E4 will be equal to 2Q. So 1800 into 10 power 3 Newton per Coulomb. So you got all the 4 values of E1, E2, E3 and E4, and you have their directions. So the important point over here, please note it down, I wrote in a squiggly corner over here that the diagonal of a square is root 2a, therefore semi-diagonal will be a by root 2. I use that idea to solve this. So I've got the electric fields, I'm still not done with the problem. So let's go on and write it. So you have E1, E2, E3 and E4. Now if I look between E1 and E3, the resultant of E1 and E3 will be, they are in opposite directions, so it will be E1 minus E3. What was E1? E1 was 1800, E3 was 900, subtracted, what do I get? 900. Therefore resultant will be 900 into 10 power 3 Newton per Coulomb. And what direction will be? E1 is greater, therefore it will be, the resultant over here will be this way, 900 into 10 power 3. Now resultant of E2 and E4. Now E2 and E4 are same direction, opposite direction, they are opposite directions, and E4 is greater, check it, E4 is 1800 whereas E2 is 900. Therefore it will be E4 minus E2, 1800 minus 900, once again 900 into 10 power 3 Newton per Coulomb, but E4 is greater, therefore this will be the direction of the resultant, 900 into 10 power 3. Now this is a square, and a square the diagonals intersect. What is the angle between the diagonals? It is 90 degrees. Therefore theta in this case is 90 degrees. What is cos of 90 degrees? Cos theta is 0. Therefore your E resultant at O will be nothing but 900 into 10 power 3 the whole square plus 900 into 10 power 3 the whole square plus 2ab cos theta became 0 whole to the power half, which is nothing but a 9 root 2 into 10 to the power 5 Newton per Coulomb, and 9 into 1.41, which is approximately 12.7 into 10 power 5 Newton per Coulomb. That would be your answer. Let me just check if my answer is correct. Yep, 1.27 10 power 6 or 12.7 10 power 5. Okay, let's recap once again. What did we do in this problem? We had 4 charges, therefore I need 4 electric fields. My first step was to calculate the 4 electric fields E1, E2, E3 and E4. In order to get the electric field, I need to know the distance between the charge and the point O, and I know for a square the diagonal is root 2a, therefore semi-diagonal is a by root 2. So using that value I found out E1, E2, E3, E4 for my 4 charges. Next I looked at the directions. If I look at E1 and E3, they are opposite to each other, so I can subtract. Resultant is E1 minus E3. E1 was greater, therefore the direction is along E1. So the direction along E1 was like this. Yeah, I'm just drawing it repeatedly. Now when I looked at E2 and E4, they are opposite to each other, so they will also subtract. Resultant is E4 minus E2 because E4 is greater than E2 and the direction is along E4. Now these two vectors are at an angle. When I place them tail to tail, the angle is 90 degrees. Cos 90 is 0. Therefore my resultant field is E1 squared plus E2 a squared plus b squared plus 2ab cos 90 becomes 0, simply a squared plus b squared whole power half, and comes out to 12.7 in 10 power 5 newtons per coulomb. Okay, once again, if you have any doubts, you can WhatsApp to the number 72590 40704 A teacher is staying live. Renuka sir is actually there. He will be happy to answer your questions and doubts today. Okay. Correct, I got the answer. Okay, let's do one more example. A charged oil drop is balanced by its own weight in an electric field of intensity 10 power 5 Newton per coulomb. If the mass of the drop is 0.1 grams, calculate the charge on the drop. This is the basis of Millikan oil drop experiment. That's how he found the charge to mass ratio of an oil drop, is by doing this experiment. Yeah. So the weight of the drop is balanced by the force due to the electric field on the charged oil drop. Find the number of electrons removed from the drop. You remove the electrons, it becomes positively charged, and the electric field, the force due to the electric field, balances the mass mg. Okay, so important point, mass is 0.1 grams, the electric field is 10 power 5 Newton per coulomb, g is 9.8 meter per second squared. I want to say q equals how much and n equals how much. I need to find what is the charge on the drop, calculate charge on the drop, and also calculate number of electrons removed from the drop. Yeah, simple, no big deal. Let's go on. Recap, I hope you remember from the definition of electric field. Electric field is defined as the force experienced by a unit charge placed at that point, or electric field E is equal to F by Q, or E bar is F bar by Q, or the electric force F bar is nothing but Q times E bar. Yep, that's the first point. So if my electric field is upwards, E bar, and I have a charge Q, it will experience a force Q into E upwards. Now the body has a mass m, the oil drop has a mass m, therefore it will have a weight. What will be the direction of that weight? It will be downwards, and the magnitude of the weight is nothing but mass into g, mg. You have QE upwards and mg downwards. If it is at rest, implies the forces balance each other, or QE equals mg. Therefore, what will Q be equal to? Mg by E. That's your answer. Now you have to plug in the values. It has all to be in the same SI units. Always make sure you convert them to SI units. So in this case, what was m? M was 0.1 gram. 0.1 is gram in SI unit? No, the SI unit is kilogram. So into 10 power minus 3. G was 9.8 meter per second squared. Is that SI unit? Yes, so no problem. Divided by electric field is 10 power 5. 10 power 5 Newton per coulomb. Therefore, this is equal to 9.8 is equal to nothing but 9.8 into 10 to the power minus 9 coulombs. So your charge on the oil drop is 9.8, into 10 power minus 9 coulombs. 5 became minus 5, minus 3 minus 5 is minus 8, and minus 1, so minus 9. That's the first part. First part was find the charge on the drop. That we've done. The second part was to find the number of electrons. What's the charge per electron? Yes. So charge per electron. So we have the charge on the drop is nothing but number of electrons in the charge per electron, implies number of electrons is Q by E. Charge per electron is so use the value, substitute that. So nothing but 9.8 into 10 power minus 9 divided by 1.6 10 to the power minus 19. Now divide it. So 9.8 divided by 1.6 comes out to be 6.12 into 10 to the power minus 19. So 10 power 10 electrons. So number of electrons that need to be taken out is 6.12 into 10 to the power 10 electrons, and the actual charge on the body is 9.8 into 10 power minus 19 coulombs. Let me just check and see if my answer is correct. 6.1 10 power 10, 6.12 10 power 10. Okay, I'm sorry about that. Momentarily I just blanked out on the charge of an electron, and I didn't want to say something wrong. I just looked it up and give you the value. Yeah, so 1.6 10 power minus 19, and you have the number of electrons that is to be removed. So that then would be the Millikan oil drop experiment for you all. So I think that's the last example that we have to do today. So if I was to recap what we learned today, we learned about vector addition of two or more electric fields. Very important, R is equal to E1 square plus E2 square plus 2 E1 E2 cos theta whole raised to the power half. That is the only thing that I taught you all today. The trick over there, please keep in mind, is your direction of theta. Theta is taken when you place the vectors tail to tail. Just tell it aloud in front of the computer. Don't feel foolish. It has to get into your head. When you find theta, you have to place the electric fields tail to tail. We've also solved finding the resultant electric field when two charges are the corners of a triangle. We did for a right angle triangle. We also did for a equilateral triangle. Both we solved. We solved for resultant field when charges are in the corners of a square. You can have them in the corners of a hexagon or any other diagram that you want. Simply find the distance, find the field, find the angle between the fields, and get the answer. You may ask me, we did a problem with the square where there were 4 electric fields. Then if the fields are opposing each other, you take 2 at a time and find the resultant. Then you finally have 2 fields with an angle between them, and you can use the formula E1 square plus E2 square plus 2 E1 E2 cos theta whole power half to get the answer. You may ask me, sir, what happens if my electric fields are in random directions? Then one way of solving them is to take them 2 at a time, find the resultant direction, and keep simplifying. It becomes very tedious. In such cases, we would take the components like we did resolution of forces, sigma fx, sigma fy. In a similar manner, we'll do sigma ex and sigma ey to find resultant electric field along x, resultant electric field along y, and then your net resultant field is simply root of ex squared plus ey squared. When we come to your competitor, we'll do those examples. As far as PU is concerned, you'll have straightforward problems only where theta is there between 2 electric fields. So what's your homework? Nothing gets done unless you do your homework. I'm very happy to see on Kaizala many of you all are submitting your homeworks. I hope you are sincerely doing your homeworks, not just copying off your friend who submitted before you. This is for your own good, so please take it seriously and do it well. So your homework is kindly review today's lecture. Your notes must be complete, pakka and thorough. If it is not, then see the video once again and write your notes and fill it up. Or better still, go read the NCERT book. You have the NCERT book with you, or else you have the PDF file. Go take the NCERT book, go through the chapter that we did on electric field, note down these points and make your notes. And then there will be a homework which will be posted on Kaizala today. Later today, homework will be posted. When the homework gets posted, please take the questions, solve them, write the answers, take a photograph, and post it back on Kaizala for us to review and to see that. Okay, so I'll wrap up my class with that today. First time I'm doing an online class like this. I hope it was helpful and useful for you all. It is a little difficult teaching without students in front of you. My apologies if I went too fast. But like I said, the advantage is you can pause your video and slow it down for the pace that you want. So I hope to see you tomorrow. All the very best with your homework. Finish it up. If you have any doubts, I think I have the WhatsApp number over there. Yep, you can still WhatsApp it, 72590 40704. You can WhatsApp it and get your doubts clarified. Complete all your homeworks. All the very best, but most importantly, take care and stay safe. Our Prime Minister was not kidding when he told you there's a Lakshman Rekha outside your house. Do not step out. So I request all of you all kindly stay in your homes. Do your routines. Try to lead as normal a life as possible, and continue with your studies and keep yourselves occupied. Yes, thank you very much, and God bless you all.